We are going on with question 3 of June 2024, paper 1. Question 3.1. Consider the quadratic number pattern of 3, 7, and 12. Show that the general term of this number pattern is given by Tn is equal to a half n squared plus 5 over 2n. When they say show, it actually means calculate. You're not allowed to simply substitute n with 1 and then show that term 1 is equal to 3, or substitute n with 2 and show that term 2 is equal to 7. So for the first question, we have the pattern of 3, 7, and 12. The first differences is 3 to 7 is 4, and 7 to 12 is 5. And then the second differences, so from 4 to 5, I need to add 1. Now remember that 1 would be equal to 2a, the 4 would be equals to 3a plus b, and the 3 would be equal to a plus b plus c. So now we can solve a, b, and c. So 2a is equals to 1, therefore a is equals to a half. 3 times a half plus b is equal to 4. So when I solve b, I have 4 minus 3 over 2, and that becomes 5 over 2. And a plus b plus c is equal to 3. So I have a half plus 5 over 2 plus c is equal to 3. And when I simplify, I have 3 plus c is equals to 3, therefore c is equal to 0. So therefore, the general term is an squared plus bn plus c. And a's value is a half, and b's value is 5 over 2, and c is simply 0, so we don't have to say plus 0. The second question says, what number must be added to Tn minus 1 so that Tn is equal to 13,527? So what I would like to do is find the position of 13,527. So we know that's part of the pattern, and I set Tn as equals to a half n squared plus 5 over 2n. So I'm replacing that Tn with our equation. Now I'm going to solve for n. So I'm going to multiply everywhere by 2, and that becomes 27,054 is equals to n squared plus 5n. So when I multiply by 2, it gets rid of the half and it gets rid of the 5 over 2, so the denominators of 2. Next, I can write this in standard form. So we have 0 is equals to n squared plus 5n minus 27,054. Now I will use my calculator to solve for n. So n is equals to 162, or n is equals to negative 167. Now because this is a number pattern, we know that n, which is a position in the number pattern, cannot be negative. So therefore, n is equals to 162. That means that term 162 would be equals to 13,527. Now the question said, what must be added to Tn minus 1 so that Tn is equals to that value? So we found the position of Tn. Now we need to find the value of Tn minus 1. So that's the term before Tn. So if Tn is 162, or term number 162, then term n minus 1 would be term 161. What I can do now is I substitute n with 161 in my original formula. So that gives me 13,000 363. And the question said, what must be added to term 161 to get to 13,527? So I simply take the difference between the two terms. So it is 13,527 minus 13,363, and that is 164. So I need to add 164 to Tn minus 1 to get to Tn. Question 3.2. Given an arithmetic sequence with term 1 is equal to 8 and term 2 is equal to 11, calculate the value of n if Tn is equal to 41. So if term 1 is equal to 8, then we have the a value as 8. And if term 2 is 11, we have the constant difference, because that's what arithmetic sequence means. So the constant difference is term 2 minus term 1, and that is equal to 3. So from our formula sheet, we have Tn is equals to a plus n minus 1 d. And we want to find n. So Tn is equals to 41, a is equals to 8, n minus 1 times 3. So if I take the 8 over, I have 41 minus 8, which is 33, is equals to n minus 1 times 3. Then I can divide both sides by 3. So 33 divided by 3 becomes 11, is equals to n minus 1. And therefore n is equal to 12. 3.2.2. A new arithmetic sequence P is formed using the term position and term value of the given arithmetic sequence. For the new sequence, P8 is equals to 1 and P11 is equals to 2 and so forth. Write down the value of P41. So in the previous question, we found that term 12 is equal to 41. So what I simply need to do is swap these two numbers. So P41 would be equal to 12. Question B reads, calculate the value of the first term of the new arithmetic sequence. So they tell us that the sequence is arithmetic, so we know that it has a constant difference between terms. We know that term 8 is equal to 1, that term 11 is equal to 2, or sorry, we can make it P11, and that P of 41 is equal to 12. So P is the notation they use in place of T. So that's term 8, term 11, and term 41. So if our rule for an arithmetic sequence is Tn is equals to a plus n minus 1d, and we replace t with p, then Pn is equals to a plus n minus 1d. And with this information, they want us to calculate the first term, so we need to find the a value. So let me substitute that information into P8. So P8 is equals to 1. I don't know what a is, plus n minus 1 d, but we know that n is equals to 8 because that's the 8th term. So if I simplify, I have 1 is equals to a plus 7d. Let me do the same for P11 or term 11. I know that term 11 is equals to 2. I don't know the a value. I know that n is 11, so it's 11 minus 1 times d. So therefore, we have 2 is equals to a plus 10d. And can you see, we now have two linear equations. And what we can do is solve these equations simultaneously. So I can see that a would be equals to 1 minus 7d in the first equation, and in the second equation 2 minus 10d would be equal to a. So now I have two equations for a, And if the a value is the same, that means that 1 minus 7d would be equals to 2 minus 10d. And if I solve for d, I have 2 minus 1 is equals to 10d minus 7d. Therefore, 3d is 1, so d is equal to a third. And I take that value of d and I substitute it into any one of the two equations for a. So it's 1 minus 7 times d. So therefore, a is negative 4 over 3. So the question is a little bit tricky because they give us t in the form of p. So they're replacing tn with pn. So that's the first thing that you need to recognize. And the second thing that they do is they take the term number and that becomes the actual value. And they take the value and that becomes the position. From there, you can use simultaneous equations to solve A. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.